This week we will be working with levers. So let's take a few student notes on levers. What I do want to tell you is I will be going through the student notes today. If I'm going a little fast, I'd like you just to kind of sit back and listen and pay attention, and then pause the video at the end and fill in the blanks. I will pause briefly between the things on our note sheet here, but if I don't give you enough time to get it in there, just pause the video at the end and fill everything in. The one section that we will not be doing just yet, we will be doing this after the experiment, are the things to remember at the bottom. So we'll do the top of this page now, and we'll do the things to remember after you watch the videos. So you'll want to make sure you keep this note sheet handy. All right, let's take a look. And as I said, we will be doing levers today, and the first thing we need to know is, what is a lever? So a lever is a mechanism that, using a fixed pivot point, can transmit force, as in raising a weight at one end by pushing down on the other. Okay, so you can either push down on that other end, or I suppose you could pull down from underneath, depending on where you are and how it's positioned. But a lever is a mechanism that, using a fixed pivot point, and in our picture right here, this fixed pivot point is the books that you see the boy working with, and he can transmit force, as in raising a weight at the one end. Okay, he's raising the box, the weight at the one end, by pushing down on the other. And you can see he's pushing down on the other end of the board. In our case, we will be actually pulling on the board so that we can see what kind of effort we have to put into pulling that down. Okay, so we'll put little hooks on our board for our experiment, and we'll be pulling down so that we can use our pull scale. All right, the next one here says fulcrum, the pivot point between the weight and the end you are applying force to. Okay, so the fulcrum is the pivot point between the weight and the end you are applying force in. And in this case, you can see it as the books, and the most simple of fulcrums, or the first order of fulcrums, the levers, the most simple order of levers, the fulcrum is in the middle. We will be doing some experiments with the fulcrum not being in the middle, but it is the fixed pivot point, okay? As in always between, but it is most commonly between the weight and the end you're applying force to. All right, here we see our F, our R, and we are adding two other things to learn about concerning levers. We have DL and DE. Okay, so let's take a look at the F, effort force. Our F isn't really changing. Effort force, and the amount of force necessary to move a weight, okay, or an object, however you want to say that there. So the effort force is the force that young man is putting into pushing down, okay? So he has the effort force. Excuse me. R is load force, okay? And this is the weight or force that needs moved, okay? So the effort force is being applied by the boy. The load force is being applied by the box in our picture here. All right, DL. Now this is something new, okay? Our DL is the distance from the load to the fulcrum. DL, distance from the load to the fulcrum. So you can see there, they make it DL because it's talking about the distance from the load, okay, to the fulcrum. So, and the fulcrum is that fixed pivot point. All right. DE is the distance from effort force to the fulcrum. Okay, so they call this DE because it's talking about the distance from the effort force. So that's where they get the DE. If you can see in our picture here, it gives examples of the DL and the DE. The DL is from that white box to the triangle. That's the distance from the load to the fulcrum. And the DE is from the triangle over to the arrow that's pointing down to the F, which is the effort force that you're going to have to put in to move that box. Okay? In general, the effort force can be expressed as F equals R times DL over DE. If you notice there in the blue, it says order of operations says it doesn't matter if you multiply or divide first. So you could also say F equals R times DL divided by DE. So whichever way works best for you, given maybe the numbers that you are working with. So those are the same formulas, just order of operations, however you want to do that. If you are trying to find out what the object weighs that you're moving, and you know the effort force, the force you're putting in, then you can just divide that effort force by DL over DE. So those are some formulas that we may be using throughout the week here on levers. So this is your notes for levers. Keep a hold of this paper because we will be coming back after the experiment videos to fill in things to remember. Okay?